Let's turn to another tiny magnetic interesting story. ScienceNews.org says how to make tiny metal snowflakes in molten gallium zinc formed symmetrical hexagonal nanostructures. This is in pools of molten gallium. Physicist Nicolas Gaston and colleagues grew zinc nanostructures with symmetrical hexagonal crystal framework. Such metal snowflakes could be useful for catalyzing chemical reactions and constructing electronics, they said. Self-assembly is the way nature makes nanostructures. We're trying to learn to do the same things, figuring out how to craft tiny, complex metal shapes in fewer steps and with less energy could be a boon for manufacturers. So, Dr. Yu, what are some takeaway things we might want to learn from in this story? I'm looking at the picture of these tiny metal snowflakes. Very interesting.
Right. I wanted to talk about the physics. So why we can make why snowflakes, so beautiful and symmetric and this wonderful structure can forming from water condensation, the water, crystallized. Once it's getting cold, crystallize and become a snowflake. And now we have an exact same pattern can form from metal from the tiny metals. So basically, they said that if we use a gallium, as a medium, and melting, because gallium will make metal soft, and if we warm them, it becomes liquid. At this state, once the metal, so after melting, right? Now once the cooling down started, the metal piece, so that's zinc metal, started crystallizing, will form exactly the same pattern, just like snowflakes, just like a water, frozen and crystallized become snowflakes.
Yeah.
So I want to talk about what's the reason why you have an exact identical phenomena. So let's use water snowflakes. Say it's a magnetic behavior phenomena. When you have tiny magnetic particles, why it has in liquid form, so those tiny particles can floating, right, can move. But once they are slowly cooling down, they are in motion, they can allow to float, and then they interact through magnetic poles. And the magnetic pole create the attraction force and the repulsion force, so that's why it will form a certain pattern. So people might think about why we always see symmetric pattern in the snowflakes. You always be able to find symmetrical axis. And the symmetrical patterns, that's exactly what magnetic behavior. So if you play a bunch of magnetic balls, if you throw magnetic ball into put them together, you always find that they will form a symmetrical pattern. So that's I will try to say. So all the symmetry in the leaves, in the snowflakes, or even in biological beings, in human or in animals, even in fishes, everything has a symmetric. So where comes the symmetric? Because a fundamental property of magnetism will form symmetry. So that's why everything stabilized structure, you always will see a symmetrical pattern. So in this case, so snowflakes have this symmetrical pattern, but if you observe this kind of zinc, mixed with gallium, this one or this medium, and make it water form. When they cooling down, they will form exactly like snowflakes. What that means? The fundamental particles, the atoms, water atoms or the atoms in the zinc elements, they are just like a bar magnets. They just act like bar magnets at a certain environment. You let it slowly free to move, slowly cooling down. That means slowly interact each other, allow them free to move. You always form this kind of symmetric structure. So what the take is, I try to emphasize one thing: the fundamental particles in this universe, in our universe, is only one particles. It's magnetic particles. It's just like a bar type of bipolar magnetic particles. And so that's why it's no surprise if you have the similar conditions, allow them in liquid form and gradually cooling down, they are crystallized. When crystallized, so now the individual magnetic pole interact. They form this pattern. Does that make sense to you?
Yeah, that makes a lot of sense. It's very interesting. There's so many similar patterns you can find in nature, the similar properties, because there's one particle, one law, one universe structure that's kind of being repeated over and over again, right?
Yes, that's what the whole universe was founded of. So I want to emphasize one thing. Whenever we're talking about the snowflakes, you will see several leaves, right? Different leaves. So why we always see, number one, we see symmetry, right? But also what do we see? We see leaves next to, between the leaves always have gaps, right? So why, and also the leaves always keep an equal distance. People might ask, how could they form such a uniform, equal distance? What force make them? Magnetic repulsion. If you have a magnet, pull a bunch of, like say, nails on one side, you will see between these nails, they were spread because the like pole against each other, right? Repel. So you will see these nails were separated, like spreaded like a flower, spreaded. So that's what happens to snowflakes, those leaves. They're always equal distance apart because magnetic force keep them apart.